Okay, let's dive right into this. Today's explainer is unpacking a real game changer from Qool Energy. We're talking zero carbon power and cooling solutions. And here's the wild part. The secret ingredient is a chemical you probably associate with cleaning your kitchen floors. Yup, we're talking about ammonia. And it turns out it's actually the key to surviving what industry experts are calling the energy cliff. So, I want you to imagine something for a second. Picture our most critical infrastructure just shutting down. Not from a hurricane or an earthquake, but simply because the traditional power grid literally cannot keep up with the massive, hyper-localized power and cooling demands of our modern world. I mean, we're asking more of our infrastructure right now than at any point in history, and honestly, the capacity just isn't there to handle it. Here is our roadmap for today. First, the looming energy cliff. Second, ammonia as the clean energy hero. Third, unpacking the AFP process. And finally, we'll look closely at the 1 to 10 kilowatt mobility line.
Part 1. The looming energy cliff, when demand outstrips capacity.
Okay, so driven by this massive explosion in AI computing and the rapid expansion of critical assets globally, we are staring down a desperate societal need for immediate, localized, zero-carbon energy. But what's really interesting and frankly a bit shocking about these timelines is the brutal reality of traditional grid connection. You're looking at waiting over 10 years. Even if you try to cheat the system and bypass the grid with traditional gas turbines, you're still waiting 7+ years from the moment you ordered to actually getting supplied. Traditional infrastructure is just crawling compared to our immediate needs. And look, this isn't just a tech problem confined to massive data centers. Take the maritime industry, for example. Global ports and the International Maritime Organization are actively phasing out hydrocarbons right now. They desperately need clean auxiliary and shore power. Plus, you've got off-grid critical applications that urgently require high-resiliency solutions. We're talking telecom towers, utility SCADA systems, which are basically the remote control networks for industrial hardware, and transportation signaling. These are the invisible nervous systems of our society, and they are all barreling right toward this energy cliff. Which brings us to part 2. Ammonia, the clean energy hero, moving beyond hydrocarbons.
Now, when you hear ammonia, your brain probably jumps straight to that harsh-smelling bottle under the sink, right? Or maybe agricultural fertilizer. But Qool Energy, bringing 15 years of clean energy experience to the table, is essentially unlocking ammonia to solve this massive capacity crisis. In the energy space, green ammonia is defined as a highly scalable, extremely dense, carbon-free energy carrier. It's an incredibly potent, affordable alternative fuel that is primed to basically supercharge our global decarbonization journey. It carries the massive energy we need entirely without the carbon emissions we're desperately trying to get rid of.
Part 3. Unpacking the AFP process, the science of zero-carbon energy. Let's move to this and see exactly how this technology builds on that chemical potential.
Before we get into the literal nuts and bolts of the conversion, I really have to emphasize this dual value output because it is brilliant. The AFP system doesn't just pump out electricity, it simultaneously tackles a massive, often overlooked secondary problem for off-grid assets: the heat. This system gives you zero carbon electricity, sure, but it also captures usable energy for industrial cooling. So you're getting two absolutely critical outputs from one single integrated platform. It's essentially the ultimate 2-for-1 deal for modern infrastructure. So how exactly does this magic happen? Step 1, green ammonia enters the system, acting as our super dense, carbon-free energy carrier. Step 2, the AFP conversion kicks in, turning it into usable electricity without a drop of carbon. Now, usually, the thermal energy produced during this kind of power conversion is just wasted, literally vented out into the sky. But here, in Step 3, that heat is actively recovered. Step 4, it's immediately used to drive industrial absorption cooling, giving us that vital second output. And finally, Step 5, built-in capture controls scrub out any nitrogen oxides, or NOx, ensuring the whole setup easily meets the absolute strictest safety and emission standards. Part 4, the 1 to 10 kilowatt mobility line, resilient off-grid power. Let's look at how this is actually deployed in the field today. This updated mobility line is engineered specifically for those critical off-grid applications we were talking about earlier. Think telecom towers, those utility SCADA systems, train control signaling. Systems that absolutely, under no circumstances, can ever go down. And they're often sitting out in remote areas where grid connection is literally impossible. Crucially, this line delivers this highly localized power completely carbon emissions-free right at the point of use.
Now, take a look at this number, 6. In the context of remote infrastructure, this is a total game changer. The mobility line offers over 6 months of continuous operation without ever needing a refill. Think about that for a second. Imagine a train signaling system up in some remote mountain pass. Instead of dispatching a diesel truck out there every few weeks to refuel a dirty generator, you drop this system in and it just runs, cleanly, continuously, for over half the year.
And this brilliantly illustrates how Qool Energy doesn't just stop at remote mobility. They scale this tech up massively for commercial operations. The Agility line pumps out 150 to 600 kilowatts for off-grid modular applications like data centers. It's packing N+2 redundancy, meaning multiple layers of backup, and 5 sigma uptime. That translates to 99.999% reliability, complete with optional combined heating or cooling. And scaling up even further is the utility line. We're talking 1 to 3 megawatts here. This is built for permanent power infrastructures and full-scale microgrids, delivering a staggering 10,000 hours of continuous use before you even need to look at maintenance. Which really brings us to the core thesis of this entire explainer: carbon-free power and cooling, ready today. With head offices in Vienna, Austria, and Las Vegas, Nevada, the team at Qool Energy isn't just writing white papers and theorizing about the future of the grid. This is highly resilient, fully deployable technology that is ready right now to bridge the massive gap of the energy cliff.
So the crucial point is this. We are waking up to a reality where our traditional power grids simply cannot move fast enough to support the future we're trying to build. The delays are just too long, the energy demands are skyrocketing, and the environmental cost of sticking to hydrocarbons is way too steep. But knowing that a highly scalable, high-density, zero-carbon alternative like ammonia-fueled power exists and is ready today, the real question is your infrastructure ready to go off-grid and zero-carbon? Definitely something to think about. Thanks for learning with me today, and I'll catch you in the next explainer.